Okay, so now let's solve for our sample problem number 1 for the motion of the projectile for the module 5. So man itong problem, no? The ball is kicked from point A with an initial velocity of 10 meters per second. So ang atong initial velocity at point A is 10 meters per second. So here, instead of using VO or V naught or V sub O, atong gigamit since point A man, then we can denote it that the initial velocity at point A is just equal to V sub A is equal to 10 meters per second. Determine the range R and speed when the ball strikes the ground. Okay, so this is it is shown here that the angle is 30 degrees ang iyang pagka-projectile, and then paingon siya diri. Okay, so this is the problem. We were asked to solve for the R. If you notice the motion of the projectile, ang from this point to this point has the same elevation. So instead of using the solution here, nga taas, no? We solve for y. Then here, nag-solve po siya v. Though we can substitute this one to x gani, or x is equal to x naught plus a voxt, diba? So ang x is just the r in this case, range x naught plus a vo cosine theta t. So this is 0, then our r is just equal to the initial velocity cosine 30 degrees times the time 1.0194. Then we can get that the r is just equal to 8.83 meters. Instead of the taas-taas pagkag-agi diri. And instead of solving twice, if you remember our previous example, no, katong na ay scenario ngayon ani that the starting and then the final position of the projectile or the particle is on the same elevation, we can solve for this form. We have this formula, right? X is just equal to the square of the initial velocity sine 2 theta over the gravity. So x is just equal to r. So we replace that with r. So okay, diri paingon diri is r. So r is equals to v naught squared sine 2 theta over g. Our initial velocity is 10 meters per second. So 10 meters per second squared times just this one, sine 2 times the 30 degrees angle over the gravitational acceleration, 9.81 meters per second squared, since this is SI, so SI itong gravitational acceleration. And we have R is equal to, so 10 squared sine 2 theta, 2 times 30 over the gravitational acceleration, 9.81 meters per second squared. We have R is equal to 8.828, or just equal to 8.83 meters. So same thing. So if you already remember this, know this by heart, and you know nga magamit kini siya if ang initial and final position of the particle is on the same elevation, and it means you can directly solve for the R without solving for the time na.